Hi students, I'm Professor Sage Fernetovich and I'm here to talk today about cannabis plant nutrition. This is the first video lecture in a two-part series on cannabis plant nutrition, and I am posting this on the YouTube site and on our class Moodle page. It might surprise you to hear that cannabis requires similar nutrients as tomatoes. This picture is showing some really basic nutrient exchanges with a general plant. And we're going to talk about this first, general plant nutrition, and also look at our cannabis as a specific type of plant and how its specific requirements can be met. So if you think back to our previous talks, what we have here is a seedling, and we can see three of the vegetative organs of a plant: the stem, the leaves, and the roots. Now, in the leaves, we have some nutrient exchange here, as you can see by the CO2, H2O, and O2. That's carbon dioxide, water, and oxygen. Carbon dioxide is part of our atmosphere, as are water vapor and oxygen. But the interesting thing is that there is less carbon dioxide in terms of density and concentration inside a plant leaf than what's floating around us. So the plant will take in carbon dioxide through diffusion. How does that happen? Well, on the underside of many leaves, including cannabis, are little holes called stomata. They look kind of like this, and my hands are representing two cells on either side of the hole. Those are called guard cells. Guard cells can cause the stoma, that's singular for stomata, that hole, can cause the stoma to close and open. So the guard cells can move. When the stomata are open, CO2 can get into the leaf. Oxygen can leave the leaf, as can water vapor. So some plants have developed an adaptation by which they can close the stomata by flexing those guard cells during hot and dry conditions. This prevents water loss from the leaf, and those plants can open up when it's cooler or dark out, letting the gas exchange occur. So cannabis has those little holes, and that's how carbon dioxide gets into the plant. Carbon dioxide is one of the important ingredients for photosynthesis. Another important ingredient, the other major ingredient, is water. Now, water is shown here leaving the leaf. That's a process called transpiration, a special type of evaporation through leaves. But water is absorbed through the plant, through the roots. Some minerals and oxygen can be absorbed by the roots as well. The water, however, will travel up the vascular system of the plant into the leaf. It's at that point that the water and the carbon dioxide combine together with the energy of sunlight to make sugars for the plant. All plants need to do that. They do photosynthesis by combining the CO2 and the H2O. Bam, energy of sunlight, we get sugar. We also get oxygen as a byproduct, shown leaving here. And the sugar, what's that doing for the plant? Well, not all plants are sugary or sweet to the taste. The plant will convert those sugars into ATP, which is an energy currency for the cell. So ATP stands for adenosine triphosphate. And ATP can be used for the cell to grow, reproduce, make terpenes, anything that the cell needs to do. So I often describe the glucose, the sugar that's made through photosynthesis, as a block of gold. Well, you can't actually take that block of gold and buy anything with it in our society. I can't take a block of gold or a gold coin down to the general store and buy a pack of gum. I need to convert that into cash. And ATP is like that cash. So then that ATP can be used for cellular activities. So CO2 and water are two major nutrients that a cannabis plant needs, and it gets it usually readily through its environment. Sometimes, of course, we have to irrigate. And some growers will pump in extra CO2 into their grow operations to provide additional carbon. But we're going to talk more about some of the additives, the soil amendments that we can supply to cannabis to make it grow. But keep in mind, a lot of what we see will apply to tomatoes as well. And that might sound weird, but we can grow tomatoes hydroponically in a greenhouse or out in a field with soil. And cannabis can go the same way too. So this is highlighting what's going on in the soil, just to show you what the roots are doing. Here we've got root hairs coming out of the root, interacting with soil particles and water and air spaces. And down here we can see some of the nutrients of the soil: copper, potassium, magnesium, calcium, being exchanged with the root hair. They can diffuse into the root hair. There are tiny holes in this piece of plant tissue that allow for exchange of these small little particles. These are actually charged atoms called ions or cations. They're positively charged, and they can be absorbed by the root. So here are some of those fertilizers and soil amendments that we will find for cannabis. Many cannabis fertilizers and soil amendments are expensive, and they seem to be more expensive when they are geared towards growing cannabis. So keep in mind that there are a variety of things to choose from. And when you are growing for yourself as a hobby grower, you might not care too much about how much you spend, or maybe you care a lot. If you are growing for a company or a grow facility, if this is a business for you, then you might be a little bit more careful in your record keeping and do more cost-benefit analysis here. So these are hydroponic amendments, we have soil amendments, we've got pH adjustment, all kinds of things, and pH monitors and soil moisture sensors. There's going to be a big difference depending on how you're growing. So if you are growing for yourself, you might be growing indoors with hydroponics. And if you're doing that, you're going to require certain fertilizers and even fertigation, where you combine fertilizer and irrigation. If you're growing outdoors, you may require much less. For example, growing outdoors this past summer, I had a couple cannabis plants in a raised bed with compost, and I supplied it with seaweed, the seaweed extract fertilizer. It was fairly cheap, and I would say that my inputs for my cannabis plants were less than $30. And from those plants, I got about a pound of dried material per plant. So the cost of the fertilizer was very low compared to the cost that I got from my plants, the dollar value. That's a lot of cannabis. Of course, I didn't have to worry about light or setting up fans or setting up a complex hydroponic system. It was very simple, very easy outdoor system where I just watered with a watering can and fertilized a couple times a week. But if you're growing indoors, you will have more of those inputs: the light, the fans, and hydroponic or soil amendments that you need to monitor more closely. If you're working for a grow facility, you may see something like this. Now I'm showing you this picture. It's a fertigation system so that you're not shocked when you first see one of these. I know when the first time I saw something like this, I thought, oh my goodness, this is so complex. But what we have here is an electronic setup with fertilizer being pumped with water at specific amounts that are set by the cultivation assistant or the cultivation manager at a facility to be delivered at a certain rate. So This is a nice, easy way to make everything, when you have many plants, uniform. So you don't want to have any problems with mixing your fertilizer and diluting your fertilizer or watering one plant more than another. This allows for uniform distribution of those plant nutrients. And it's they can be easy systems to operate. They can be hard too. And each grow facility might have something different. This is from Climate Control Systems Incorporated. But this looks like something that we have for the sustainability department at HCC in our freight farms. So just want to give you a little heads up about that. Of course, I do want to point out that if you have something like this, it is a good idea to have a generator backup in case power goes out. Of course, for lights, that's also important, but you wouldn't want to miss important fertigation because of a power outage. So plants require certain nutrients to grow. We talked about CO2 and H2O, their importance in photosynthesis, but there are other nutrients that a plant needs to complete its life cycle, from seed to mature plant to flower, and then fruit if you are looking for seeds. Not everybody does, but people who are interested in genetics and breeding want to get viable seeds. In any case, there are 17 essential nutrients that are required for plants. Many of these are acquired through soil. Soil amendments help. If you're doing hydroponic growing, you will have mixtures of these essential nutrients. And they're listed here with their atomic symbols: carbon, hydrogen, oxygen, phosphorus, potassium, nitrogen, sulfur, calcium, and iron. Those are some of the major ones. And then we've got things like nickel and chlorine at the end of this list. You'll see these listed often on fertilizer labels. Now, I'm going to talk about nitrogen, and then I want you to check back in part 2 of this video lecture series for the other nutrients. Nitrogen is one that I put a leaf here because nitrogen is important for vegetative growth, most important for vegetative growth. That means as the plant grows, gets taller, develops more leaves, that's vegetative growth. That's when we really need high nitrogen. So in our soil amendments, we're going to see fertilizer with 3 numbers on our fertilizer bags, and I talked about this earlier in a lecture. The first number is nitrogen. Then we have phosphorus and then potassium, NPK. So we want to look for a fertilizer that has a high first number, nitrogen number. In hydroponics, the nitrate should dominate with a ratio of 70 to 30 nitrate to ammonia. Urea is not acceptable for media. Urea is a form of nitrogen fertilizer. And once our plants are growing and they get really nice and big, we want to reduce the nitrogen for flowering. And when that occurs, you'll want to increase the other important fertilizers. So nitrogen, start out your plants. After the seedlings have developed some of their early leaves is when you want to start applying a high nitrogen fertilizer. Don't apply it to baby seedlings. They've got to get their strength up first. You don't want to burn them as you can with some strong nitrogen fertilizers, but as they grow, supply them with plenty of nitrogen. Nitrogen is also important in chlorophyll, which makes the green for the leaves. So it helps with not only the growth, but also the photosynthesis. So see me soon. We'll talk about phosphorus, potassium, and some of the others.